All right, so here's our topic, entropy. We want to calculate a change in entropy for a reaction. So this is what we're doing, all right? How much did it, and that's our answer. It's going to be something like that. The formula we're going to use is very similar to the one we saw with enthalpy, in that it's the sum of the entropy of the products minus that of the reactants, where this is the absolute entropy. All right? And that's what this formula means. Basically, you can calculate it for a reaction by subtracting these two things. Now, I want to talk about what the signs mean, and before I do actual problem. And your signs are going to be either positive or negative, all right? And if it's positive, that means I'm making more microstates, and there are lots of causes to that. In that I could be changing from one of these phases to these, or any one of these variables could be increasing. Temperature, volume, or number of moles of gas. And a negative would be the opposite, all right? So here's our problem. Now to do these problems, the first thing you're going to need is you're going to need a balanced equation, all right? Here is the balanced equation, and you're going to need to know your standard, your absolute entropy values. They will be given to you. You won't calculate them. And it's not like enthalpy where there's zero for the elements. Pretty much everything has a non-zero value. So you're given these things, these values, all right? I'm going to switch to paper. All right. Now, if you look at this problem, I go from 4 moles of gas to 2 moles of gas. Probably going to have a negative entropy. I'm going to lose microstates on this one. So I look up my values. There they are. All right. The first thing to do is to write the equation. And then I'm going to plug everything in like that. And I'm going to multiply it by the coefficients. Here's my 2 times 192, that's because I've got 2 in the products. So 2 times this, it's going to be 3 times that and 1 times that. All right? That's what I've got here. And then I do it and subtract, and my entropy becomes negative 198.3 joules per mole per degree Kelvin. So that is telling me that I lost entropy in that equation. Not equation, but reaction. Okay, what about this one? Another problem. Here it is. We're going to need to know the the balanced chemical equation. Now you can see this one isn't balanced. 8, that's going to give me, I'm going to put an 8 there and a 9 there. All right. And now what's the variable that's going to go there? So 8, I'd need 8 of these and 4.5. So that's 12.5. All right. I wouldn't really write that as a coefficient. I'd multiply everything by 2, but I'm just simplifying the math. I'm going to look up the entropy values. And my entropy values are there. All right. And then they're all in joules per moles. All right. Then I'm going to use, there's my formula that I'm going to use. And then I'm going to plug it all in. Now, it's 8 times the carbon dioxide, so 8 times that. 9 times that value. Oh no, 9 times the water value. So 9 times 188. So that's this. This is just the isooctane, and then 12.5 is 25.2. Divide those, or multiply that by 12.5. All right. And then I'm going to do the math out. The big thing would add up to that and add up to that, and my answer is this. Now, this is a positive entropy. Now, it would make sense. I have 12.5 moles of gas, or 13.5 moles of gas going to 17. I'm increasing the number of moles. Therefore, my entropy should have a positive change. All right, I hope this helps, and let me know what I can do to help you. All right, bye.